Imagine the dark as a warm room. It holds a quiet that is not empty. It is full of a softness that does not press or shout. It waits. In that waiting, a breath begins. Not a gust, not a roar. A breath that lengthens itself into space. The first motion is not sharp. It unfolds like a slow tide that lifts every grain without breaking a single shell. From that first light touch, the room becomes larger than a room, then larger than an ocean, then larger than any word that could fit inside a human mouth. Expansion is not a sprint. It is a cradle that keeps widening, a patient lull that guides everything outward without forcing anything to run. He would see it if he could stand far enough away, not galaxies racing like startled birds, but the fabric between them stretching with a quiet rhythm. Space learns to be bigger. That is the gentlest fact. Nothing needs to fight for distance. Distance arrives, and it arrives everywhere at once. A star on one side and a star on the other side. Both find the night between them growing by itself. They remain what they are. Their heartbeats stay local and bright. It is the night that changes. It relaxes. It lengthens. It takes a deeper breath. Light feels this first. Light leaves a young star blue and eager, then travels for ages, and the ages teach it to soften. Wavelengths open like the petals of a night flower. Color relaxes toward red. The softening is not decay. It is the mark of a journey through a calm that keeps becoming calmer. Every redder hue is a note in a cosmic lullaby. It is how the universe tells its own age. It is how the universe measures its own ease. What began hot learns to cool. What began crowded learns to share. He would also hear the afterglow if his ears could listen that low. A whisper of microwaves fills all directions. It does not prefer any corner. It wraps the sky as evenly as frost on a winter window. It settles near 3 degrees above, perfect cold, which is another way to say it remembers when the first light became free to travel. That memory is intimate and gentle. It says the early fire did not vanish. It settled. It calmed into a background, so even that it feels like a promise of balance. The background is not loud. It hums. It keeps the same key everywhere. A key that speaks of a universe that does not tilt or lean toward any chosen place. There is kindness in the way gravity and expansion share the stage. Gravity gathers close things into families. Expansion gives those families room. A spiral galaxy spirals because nearby stars hold hands. A cluster holds because nearby galaxies nod to the same pull. Yet while the local handshakes strengthen, the large distances drift apart. No one is pushed. The stage grows. Dancing becomes easier because there is more floor. The steps do not need to change. The room changes around the steps. That is why the image carries peace. The mind can rest inside it. It can picture change without turmoil, motion without struggle, and growth without a command. The most relaxing part is how ordinary the miracle becomes. Measure in any direction, and the same story appears. The farther a light sits from this small home of thought, the more its color leans to red, and the more gently it withdraws. The pattern is simple, like waves on a shore that arrive in steady sets. The simplicity is not boring. It is soothing. It says the cosmos follows a rhythm that does not falter when a person looks away. It says the rhythm holds whether a watcher believes or doubts. It keeps time without anyone keeping time for it. He thinks of clocks and finds that they live inside light. He thinks of maps and finds that they live inside distance. Then he learns that time and distance are braided into the same cloth. The cloth itself is what widens, not the things upon it. The distinction feels small and becomes everything. Boats do not row to new harbours. The sea swells between them. The sails stay loose. The ropes do not strain. The horizon walks away. A mind that once expected noise learns to accept this kind of quiet motion. It is the quiet of a book that turns its own pages with a breeze that never stalls. The hush that widens is not empty of story. It contains every fire, every planet, every long chemistry that learns to think, and every voice that wonders how the hush began. Yet none of this cancels the calm at the heart of the view. All the turbulences are local weather. The climate is serenity. A nebula can churn like a storm, a black hole can grip like a clenched fist, a quasar can flare like a lighthouse on a cliff. Step back far enough, and the scene smooths. The storms blur into a mist. The lighthouse becomes a dot. The dot becomes a note in a chord, and the chord resolves to a tonic that never strains. The mind that listens long enough starts to match its breathing to the scale of the picture. Inhale, and the distances soften a little more. Exhale, and the colours lean one more shade toward rest. The heart does not speed up when it looks at a sky like this. It slows. It learns to take its time. It learns that patience is not a delay. Patience is a direction. Patience is outward. Patience is the way the cosmos draws its line, not with a ruler that ends at the paper's edge, but with a curve that keeps finding more page. It does not need to reach a border. It does not need to finish. It needs only to continue. What does this mean for a life that is brief and crowded and full of noise? It means that ease has a structure. Peace is not a pause between alarms. Peace can be baked into the geometry of everything, and then it can be read by anyone who looks at light with care. Look at a distant galaxy. See how it does not come closer, no matter how loudly desire calls. It will not rush. It will not break its stride. Its refusal is not cruel. It is faithful to a wider rule. The rule is gentle. The rule is the spread of space itself. That rule says every portion of the fabric will join the lengthening, and no portion will be asked to carry the whole. There is a tenderness in numbers that fit this story. They show that the rate of widening is measured not in miles per hour, but in how fast every unit of distance creates another unit of distance. A megaparsec is a giant step, and for each giant step the universe adds a little extra space every second. That little extra is small for one step, and immense when the steps add together across depths no daydream can hold. The growth is not a runaway child. It is a guardian that chooses a steady pace and keeps it, while the early fire turns to stars, and stars turn to heavier atoms, and heavier atoms turn to cells and thought. He pictures the early minutes when everything was too hot for atoms to rest. Even that fierce youth had a calm within it. The calm was order. The calm was a simple recipe made of a few abundant ingredients. As the heat faded, the recipe changed into what a gentle night sky now displays. Hydrogen glows, helium glows, a thin spice of heavier things glows. The glow is thin because the early plan was simple. The simplicity seeded the smoothness, and the smoothness made the widening graceful. It is hard to think of a softer origin for such a huge story. The most comforting truth may be this. Expansion means that nothing needs to dominate in order for everything to grow. No single galaxy is in charge. No throne sits at the center. The fabric gives itself away evenly, and in that giving every corner becomes a place where time can take its time. People often ask where the edge is. The answer that soothes is that there is no wall to collide with, no cliff to topple from, no empty beyond that needs guarding. There is only more of the same quiet fabric, more of the same gentle lengthening, more of the same invitation to breathe at the pace of the stars. The breath that began has not ended. It does not tire. It does not pant. It simply continues. To watch it is to be reminded that not all power is loud. Some power is soft and persistent. Some power is the kind that makes room. In a world of alarms, there is comfort in knowing that the largest thing that exists chooses to move with grace. It opens its hands, and everything drifts a little farther apart, and somehow that separation becomes a gift. It gives clarity. It gives calm. It gives a view large enough for any worry to find its proper size. He lived with two kinds of quiet. One belonged to the chapel where the floor held the weight of footsteps and the ceiling stored the soft echo of prayer. The other belonged to mathematics, a silence pressed into symbols that could lift the mind beyond walls. Georges Lemaitre walked between these silences with a steady calm, The streets of Leuven gave him stone and sky. A small office gave him chalk and paper. He studied the field equations of general relativity with the patience of someone deciphering a hymn written in a language older than language. The lines curved, the terms gathered and cancelled. Space and time refused to stay flat. They accepted curvature the way water accepts a moonlit tide. He noticed that the standard choice of stillness felt uneasy in those equations. A universe fixed in size required a careful balancing act. The equations would permit it only if a new constant was added, a term that behaved like a pressure spread everywhere. He saw how this device held the picture steady, but he questioned whether the picture itself needed such restraint. If gravity could bend the fabric, perhaps the fabric could also learn to move. He solved the equations with the constraint of eternal stillness removed. The result was not a carnival of chaos. It was a sober path to a universe that changes size. He was not the first person to open that door. Alexander Friedman had found dynamical solutions a few years earlier, tracing possible histories that included expansion or contraction. Those solutions existed like maps rolled up in a drawer. Lemaitre pulled a particular map into the light and placed it next to the sky as observers were beginning to measure it. He knew of the spectral lines from distant nebulae, where delicate fingerprints of atoms shifted toward longer wavelengths. Vesto Slipher had recorded those shifts with a methodical devotion, turning glass plates into an early census of receding light. If the lines leaned toward red, the objects stood back, as if the night itself increased the space between them. Lemaitre's attention joined theory to observation with a quiet act of synthesis. He took recessed spectral lines as velocities, careful numbers drawn from the patient labour of the Lowell Observatory. He took estimated distances from the new tradition of standard candles, where the regular throbbing of certain stars allowed their true brightness to be known. With the two lists made compatible by caution and algebra, he plotted motion against distance. The pattern rose, not as a wild scatter, but as a steady climb. The farther a galaxy stood, the faster it withdrew. He could express the relation in a single sentence of mathematics, a proportionality that would later carry another man's name in popular memory. He wrote it calmly in French, published it in a journal that travelled slowly, and sent it into the world with no trumpet. He spoke to colleagues and found reluctance. Stillness felt safer. It felt like the deep assumption that did not need defending. Even Albert Einstein, whose theory had made curved spacetimes possible, kept the heart of the cosmos pinned to a constant radius with his added term. When Lemaitre met him at a conference, he described the dynamical picture and the match to redshift data. The response was firm and skeptical, yet certainty softens in the presence of better fits. The fabric of physics does not care for pride. It bends toward what survives measurement. A few years later, the world saw a clearer set of distances and velocities assembled in the same frame. Edwin Hubble used the pulsation of Cepheid stars to extend the ladder of distance farther, and with fresh confidence. The relation that Lemaitre had put on paper stood tall in the new light. Telescopes did not see space stretch in the literal sense. They saw light altered by a journey across an enlarging stage, and they saw speed increase with remoteness like notes rising along a calm scale. The universe did not need anchors at the edge. It needed a rule for change. The rule was simple. Rate equals constant times distance. Nothing else about daily life resembles such a law. The air does not drift from lungs at a speed set by the size of the room. Cars do not leave a city faster if the destination is farther. The strangeness lay in the frame itself learning to widen. His training as both physicist and priest gave Lemaitre a discipline of attention. He respected boundaries between kinds of knowledge, and inside the scientific one he insisted on clarity. He described a beginning not as a myth, but as a physical proposal. If the cosmos is expanding now, perhaps it was once smaller, denser, and hotter. He imagined a seed he called the primeval atom, not as a literal stone, but as a state where all the fabric and its energy were pressed into an early unity. From such conditions, a release would not erupt like anger. It would be the calmest possible unfolding permitted by the equations, a widening that allows the early fire to spread, cool, and give room for structure. In that picture, the observable traces would be real. A sky bathed in faint microwave light and a pattern of elemental abundances fixed when the world was young and hot. Those traces would only be searched for in earnest much later, but the outline already rested on calculable steps. He returned to the constant that had held the universe still in earlier thinking. In his hands it became something else. He proposed that this term might represent a physical energy belonging to empty space itself, a form of energy that does not thin out when space stretches. Such an ingredient would behave with negative pressure, pushing on the cosmic fabric in a way that could slow a decline or hasten a spread. The idea slept quietly in the literature, while the mid-century focused on other puzzles. It waited like a note sustained under louder themes. His clarity refreshed tools. Observers learned to treat recession as the natural language of large scales. Spectrographs improved, and workers recorded redshifts with better precision. The ladder of distances added rungs through new standards. The statistical treatment of data became kinder to uncertainty. Each improvement returned to the same relation between speed and separation. The implied age of the cosmos could be estimated from the constant that set the slope. That number changed as measurements sharpened and as corrections were made for local motions and for the curved geometry of the whole. The core fact did not tremble. Expansion remained the simplest frame for the sky. He did not argue for triumph. He argued for coherence. The equations of general relativity allowed evolving scale. The observations of galaxy spectra presented systematic redshift. The marriage of the two needed no extra drama. It needed careful accounting. He offered that accounting with a tone that kept heat low and light high. When Eddington and others read his work more closely, the circulation widened. Translations appeared. Ideas that had slept in a small French journal began to breathe in larger rooms. The picture of an expanding universe moved from one person's study to shared speech, not as a revolution with broken furniture, but as a realignment of chairs to face a window that had always been there. His proposal carried deep comfort for those who find solace in order. It suggested that the universe is not a fragile balance on a knife edge of stillness. It is a system that follows laws that permit it to be many things while remaining lawful. It can grow, it can thin, it can cool and become transparent. It can allow matter to gather under gravity into stars that forge heavier elements, into galaxies that swirl, into clusters that braid their motions. None of this required a privileged seat. Every observer in every galaxy could measure others receding, and each would write the same relation with the same constant. Centers were abolished without fanfare. That removal calms the mind. The map has no dot that demands deference. The person who noticed how simply the pieces fit continued to teach, to calculate, to refine. He did not abandon the chapel. He did not abandon the chalkboard. He let the two silences continue their separate music. In one, a devotion to mystery as mystery. In the other, a devotion to mystery as solvable structure. The expanding universe sat in the second silence and found its place in the first only as a humility. He understood that the comfort of the idea came from its adequacy to measurement, not from its poetry alone. Yet the poetry was real. A cosmos that opens rather than closes has a way of loosening the fist inside a chest. From that foundation, the sky gained a new voice. Distant galaxies were no longer strangers with private velocities. They were participants in a shared widening. The redshift surveys that would follow were already implied by the first careful plot. The clear slope on the page had the same gentleness as an evening shoreline, where each wave that reaches the beach remembers the far pull of the sea. The concept did not ask observers to chase a vanishing edge. It asked them to listen to a relation that explains why distant light arrives softened, and why large structure can grow in a fabric that keeps relaxing. The explanation was not an end. It was an invitation to measure better, to question more subtly, to wonder more quietly. Expectation likes a firm floor. For centuries, Many minds pictured a cosmos that neither swelled nor shrank, a grand hall where stars kept their distances like dignified guests at an endless reception. The shock arrived when mathematics and measurement leaned together and pointed toward change. The floor was not fixed. The hall was learning to grow. The surprise was not loud. It was deeper than sound. It unsettled a habit of thought that had felt as natural as breath. The first rupture in expectation came from the nature of space itself. Geometry had been a quiet servant, a stable grid that held positions like pins on a map. Then the field equations revealed that the grid was alive. Mass and energy could bend and stretch the very stage. If the stage can curve, it can also change its scale in time. That conclusion offended no equation, yet it startled intuition. People know motion as travel through space. Expansion is motion of space. No everyday object provides a true example. A loaf of raisin bread in the oven is offered as a picture, yet even that analogy is a compromise. The raisins move because dough expands, while galaxies do not cause expansion by their presence. The cosmic scale factor evolves because the entire content of the universe behaves collectively. The shift from travel to stretching demands a new instinct, and new instincts are always a jolt. A second shock came from velocity that ignores common limits. Nothing can outrun light when it moves through space. That rule holds. Yet recession can exceed light speed when it is the fabric that is lengthening. Distant galaxies recede faster than light without breaking a law, because no object is sprinting past a neighbor. The metric itself is swelling, and beyond a certain distance, the swelling carries galaxies away faster than signals can close the gap. The idea that parts of the universe are forever outside causal reach feels like a door locked by the hallway. It introduces horizons that are not walls and not fog, but boundaries written by time and expansion together. To learn that such limits exist is to feel small in a new way, a feeling that blends humility with calm. A third shock visited the concept of energy. In familiar physics, energy is conserved with a precision that comforts. In a static background, one can track every joule like a careful bookkeeper. In an expanding universe, there is no global energy account that remains exact. Photons lose energy as their wavelengths stretch. The loss is not paid into another ledger. It is a direct result of evolving geometry. Local conservation still reigns, expressed through the equations that govern fields and matter, yet the global picture resists a tidy sum. This is not a failure. It is a reminder that the rules of a dynamic space-time are not the rules of a stage that refuses to move. Redshift supplied another surprise of meaning. At first glance, a redder line suggests a Doppler retreat, the sound of a siren sliding to a lower pitch as it moves away. In cosmology, that analogy helps and misleads. The shift is not only a Doppler effect from motion through space, it is largely the imprint of the scale factor growing while light is in flight. The expansion accumulates along the path. By the time the photon is received, its color records the history of the journey rather than a single instant of launch. To think of color as a travel diary rather than a speedometer asks the mind to trade an old tool for a richer one. Darkness spread across the sky delivered a quiet contradiction to an ancient expectation. If the universe were infinite in age and filled uniformly with stars, the night would blaze. Instead, it is dark. The resolution lies in the finiteness of cosmic time and in the redshifting and diluting of light from far epochs. Expansion cools radiation and lowers its surface brightness with distance in a way that a static picture cannot mimic. The dark sky is not an emptiness that scolds. It is evidence that the universe had a beginning in temperature and density, and that widening has turned searing light into a faint background. A paradox becomes a lullaby when the correct frame is used. Another shock came from the absence of a special seat in the balcony. If all galaxies are seen to recede, a quick instinct searches for a center from which motion begins. The uniformity of the pattern denies that instinct. Every location observes the same law, to the degree that the large scale is smooth. Centers dissolve. The expansion is not an explosion into pre-existing emptiness. It is an increase of distance within the fabric, everywhere at once. That realization ends the hunt for a privilege point and replaces it with a principle of homogeneity and isotropy. Such modesty in the map feels strange at first and then relaxing. Time itself learned a new flavor under this view. In daily life, simultaneity is a simple word. In relativistic cosmology, a common time for the whole sky appears only under a chosen slicing of space-time. The cosmic time that matches the large-scale symmetry is a useful construction, not a universal clock hung on an absolute wall. The age of the universe becomes the proper time measured by ideal observers who ride the expansion with the average flow. To accept that time is bound to geometry, rather than handed down from above, is to relearn what it means for something to be ancient or recent. There was also the shock of scale-dependent peace. On small scales, gravity wins. Galaxies hold themselves together. Clusters bind. The solar system ignores the cosmic drift because local curves in spacetime dominate. On the grand stage, expansion smooths and separates. The coexistence of bound islands and widening sea breaks the habit of seeking one rule at all distances. Nature offers a layered order where local and global behave differently without conflict. The human mind, fond of single summaries, must learn to like two truths that share a border. Measurement deepened the surprise with a crisis of ages. Early estimates of the expansion rate implied a universe younger than some of its oldest stars. That contradiction felt sharp, a reminder that numbers are only as good as the ladders and calibrations from which they hang. Improved distance indicators, better understanding of stellar evolution, and refined accounting of matter and geometry eased the tension. What remains from that episode is the lasting recognition that a cosmic clock is built from many interlocking gears. Each gear must be polished for the time to make sense. The most delicate shock concerned pressure that behaves unlike familiar pressure. A component with nearly constant density, even as space expands, exerts negative pressure. The response of the scale factor to such pressure is not a braking but a soft push. The recent discovery that expansion is speeding up, rather than slowing stunned expectations formed during the time when gravity seemed certain to apply the brakes. A gentle acceleration born from the nature of vacuum, or from a slowly rolling field, ran against common taste. It required a reweighing of the cosmic budget and a new humility about what emptiness contains. Emptiness, it turned out, might not be empty. Finally, there was a philosophical tremor beneath the technical shifts. A universe that evolves in size and in content invites questions about origin and fate that a static universe had muted. The equations allow many stories. Some curve back on themselves, some stretch toward a cold dilution, some sit in a delicate balance. The knowledge that the real sky follows one of these paths brings existential weight without drama. The scale of the question does not demand panic. It asks for patience. It asks for a longer breath. Shock can be noisy. In this case, it was the quiet reassembly of intuition. The patterns on spectrographs, the curves of geometry, the behavior of light and pressure and time, all agreed on a new picture. The rules had not broken. They had widened to include a world where space is not a container but a participant. Expectation had to step aside. In its place, a calmer understanding took hold, one that accepts horizons without dread, superluminal recession without scandal, and a night sky whose darkness is not a void but a signature. The shock became a settled truth, and the settled truth continues to open into deeper questions that do not clamour. They invite attention. They reward stillness. The sky began to confess in fine grain. What first looked like a smooth bath of ancient light revealed a faint mottling, a delicate speckle pattern written across the entire dome. Instruments learned to listen in colder keys and with steadier hands. They mapped the microwave afterglow not as a uniform hush, but as a field of tiny temperature ripples, each one a whisper from a time when matter, radiation, and gravity bargained for balance. The pattern was almost featureless. yet not quite. The small differences carried scale, rhythm, and memory. They told of sound that once rang through a hot plasma sea, compressing and rarefying like notes in a cosmic flute. The result was a set of preferred sizes embedded in the glow, a ruler frozen into the sky. From those maps came a portrait of the whole. The average density of matter revealed itself. The portion belonging to ordinary atoms declared its modest share. The curvature of space-time on large scales looked flat within small uncertainties, as if a great sheet had been pulled smooth. Even the tilt of the primordial fluctuations could be traced, a measure of how ripples of different sizes were seeded in the first moments. Polarization patterns added another layer of truth, arranging the light into orientations that recorded the dance between photons and electrons at the time when the fog cleared. In this lattice of detail, the universe spoke in parameters that could be written in notebooks. What had been a calm generality became a measured story with values and error bars. The same ruler that hid in the afterglow left a faint echo in the arrangement of galaxies. Surveys that swept vast volumes found filaments strung like harpstrings and voids as wide as metropolises of light. Within that web, there appeared a preferred separation, a gentle bump in the statistics of how often galaxies are found at given distances from each other. This bump matched the scale of the ancient sound waves imprinted when the cosmos was still a glowing fluid. Baryon acoustic oscillations, as they came to be called, acted like mile markers along the highway of expansion. By measuring how that scale appears at different epochs, observers watched the rate of cosmic growth change with time. The method did not demand bright explosions or special cases. It asked only for numbers and patience, then returned a tempo for the widening stage. Supernovae added their steady candles to the effort. Certain dying stars flare with a near constant brilliance once their variation is corrected with care. When such a flare blooms in a distant galaxy, it allows a comparison between how bright it should be and how bright it appears. The difference yields distance, crossed with redshift, which comes from the softened color of the host galaxy's light. A curve is drawn that relates the history of expansion to time. The curve bends in a way that identifies whether gravity alone governs the expansion or whether another ingredient gently pushes. The dots that traced that bend were not hurried. Each came from years of survey, confirmation, and calibration. Together they etched a verdict that the spread is not slowing in a simple way. Something acts with the sign of a soft pressure that is unlike the pressure in air or water. Gravitational lensing taught a subtler lesson. Mass bends light, and large structures warp the paths of photons from more distant sources. When maps are made of how background galaxies are sheared into slight ellipses, the invisible is revealed. The lensing field shows where matter has collected, whether luminous or dark. By following how this shear signal changes with redshift, one can watch the growth of structure through time. The rate of that growth depends on the content of the universe and on the exact rule by which distances increase. The emerging picture showed a cosmos where matter clumps with a strength consistent with an expanding background that both enables and competes with gravity. Islands grow, but the sea grows faster. Closer to home, careful accounting of the movement of galaxies in the local volume mapped small deviations from the general drift. Clusters tug neighbors. Voids let them slip faster. These peculiar motions do not overthrow the calm trend. They decorate it with regional weather. By measuring both the drift and the deviations, astronomers gained two views of the same stage, one of the smooth rhythm, one of the local choreography. The agreement between the two views confirmed that the large scale is nearly uniform while the nearby is richly structured, a pairing that strengthens trust in the whole framework. Another testimony rose from the chemistry set of the early minutes. When the fireball was young and dense, protons and neutrons assembled into light nuclei. The amounts of deuterium, helium, and lithium that resulted depend on the density of ordinary matter. When observers weighed those elements in ancient gas clouds and in the oldest stars, they found values that harmonized with the matter content inferred from the microwave maps. It was as if two distant witnesses, who had never met, gave matching descriptions of an event, One spoke in the cold language of photons, the other spoke in the quiet speech of nuclei. Together, they pointed to a consistent account of a hot beginning, followed by a long cooling. Quasars and the diffuse hydrogen between galaxies added still finer relief. Spectra of these bright beacons carry forests of absorption lines that mark where cold gas intervened. The clustering of those lines reveals how matter is arranged on scales too subtle for direct imaging. Simulations that start with the measured seeds from the afterglow and evolve under gravity and expansion produce a structure that looks like the observed Lie-alpha forest. The matching of model to data is not a simple trick. It is a full rehearsal of the formation of structure, tested in the thin ink strokes of absorption features. This agreement deepened confidence that the same gentle rule for the global stretching guides the growth of detail. The sky also offered special alignments where massive clusters distort and brighten background galaxies into arcs and rings. These strong lenses allow two kinds of measurement. The timing of multiple images from variable sources depends on both the mass of the lens and on the geometry of the expanding universe. The shapes of the arcs pin down the distribution of dark matter within the cluster. Each kind of lensing speaks to different aspects of the same story. In the clockwork of time delays and the geometry of deflected paths, the expansion rate and the content of the whole gained sharper outlines. New instruments pushed their gaze to earlier eras, where fledgling galaxies flickered close to the time when the first stars lit. The abundance of such young systems and their brightness profiles hint at the speed with which structure assembled. The data did not erase the large-scale calm. They offered a test of it. If the widening had been slower or faster in the early chapters, the number of visible infants among galaxies would shift. The counts and colours seemed to prefer the same broad history that the microwave sky had suggested. Tensions and puzzles sprouted in details, as honest data always guarantee, but the backbone remained intact. Even silence delivered a message. Efforts to detect certain patterns in the polarization of the microwave background that would be produced by primordial gravitational waves returned limits rather than detections. Those limits sifted the landscape of early universe models, favoring gentler starts over violent ones. The absence of a signal can be as informative as its presence when the quiet is measured well. It spoke of an origin that kept the amplitude of very long wavelength ripples small, a restraint that aligns with the smoothness observed across the largest scales. As the catalogue of measures grew, cross-checks multiplied. The expansion rate estimated from the afterglow could be compared to rates inferred from supernovae, from galaxy clustering, from lensing, and from the web of intergalactic gas. The age implied by the rate could be compared with the oldest star clusters. The total amount of matter could be stacked against the depth of potential wells. The pieces formed a puzzle that wanted to lock, and most of the edges clicked. Where small gaps appeared, they invited better instruments, longer campaigns, and more careful treatment of systematics. In this way, the investigation moved from a sketch to a portrait to something close to a high-resolution photograph. The cosmos handed out rulers, clocks, and compasses that did not sit in a drawer. They were woven into the sky, temperature ripples measured in millionths of a degree, galaxy separations counted in preferred spans, supernova light curves folded into distances, sheared images translated into mass maps, absorption forests converted into fine-scale structure. Each tool was gentle in its own manner. None demanded violence from the world to reveal its content. They asked for patience and repetition, for calibration and caution, for surveys that watched the same patch many times and catalogued the same features with growing care. From all this, a theme emerged with quiet strength. The expansion is not a rumour. It is a measured process that leaves marks in many languages. Light carries one dialect, gravity writes another. The chemistry of the early fire speaks a third. Together, they outline a universe that cools as it stretches, that forms structure while the fabric lengthens, that carries a faint memory of primordial sound, and that seems to be guided in its later chapters by an ingredient that keeps distances opening more gently than deceleration alone would allow. The investigation is not a hunt for a single proof. It is a chorus where many soft voices sing a single, calming tune. Clarity can sharpen the outlines of doubt. Each new instrument polished the view, and with the polish came small mismatches that refused to blur away. The first of these felt like a clock that would not strike the same hour for every method of timekeeping. The pace of cosmic widening could be read from the fossil light that fills the sky, or from the present-day behavior of nearby galaxies and supernovae. Both approaches were careful. Both insisted on their own corrections. Yet the number that came from the ancient afterglow, interpreted through a model of cosmic ingredients, sat a few steps lower than the number pulled from the nearby universe by stellar ladders and standard candles. The difference was not huge, but it was stubborn. As calibrations improved, it did not vanish. It thickened into a puzzle of tempo. The discrepancy gained a nickname in the hallways of research. It sounded like a household dispute and carried the same quiet gravity. If the pace is faster today than the early record prefers, then either today's yardsticks are stretched by some hidden bias, or the cosmos changed its rulebook in a subtle way after the first light was released. Both possibilities invite uneasy questions. The first forces a recheck of distances and light curves and population effects in stars. The second hints at a gentle ingredient that woke later than expected, or at a modification to gravity that reveals itself only when the stage has grown wide. A mystery thickens when all paths forward require humility. A second tension grew out of how structure has assembled. Maps of the bending of light suggest that matter has clumped with a slightly different strength than some models tuned to the afterglow would predict. The number that summarizes this clumping is small enough to be written on a single line, yet it carries a landscape of assumptions underneath. If mass clusters a bit less than expected, perhaps the pressure that drives expansion also dampens growth more than a simple constant can. Or perhaps the traces of mass are biased in ways that are hard to tame. The world offered two truths at once. On the largest scales it looked smooth and flat. On intermediate scales it looked just a little too quiet. Even the grand symmetry of the sky whispered of asymmetry at the margins. An unusual alignment in the largest wave patterns of the microwave background produced a low stir among patient minds. The quadrupole seemed weaker than taste predicted. Certain modes preferred similar directions on the sky. The effect could be a random fluke, a coin that comes up heads several times in a row and then returns to ordinary behavior. Or it could hint that the initial conditions were not perfectly featureless. A harmony nearly perfect is more haunting than one that is clearly broken. The nearly unsettles more than the obviously wrong. At the same time, surveys of galaxies found vast regions with few residents and lanes where light congregates in slow braids. Within those local features, flows of matter sometimes appeared to move in ways that suggested a coherence across larger distances than comfort allows. Bulk motions can arise naturally from the tug of nearby overdensities and the release offered by voids, yet reports of unusually large flows pushed against expectation. Each claim met counterclaims. Each dataset learned from the next. Still, the very discussion underscored a theme. Calm on the whole does not guarantee calm in detail. Then came the oldest riddle dressed in new clothes. The energy of the vacuum, if treated as a straightforward sum of quantum contributions, tries to explode into a value far beyond what the sky tolerates. Theory piles up quanta-like grains of sand and delivers a mountain. Observation looks out and sees a mild hill. The mismatch is not 10 or 100. It is a chasm so wide that the human tongue resists the count of zeros. The smallness of the gentle pressure that now dominates the expansion is a fact that hangs like a light weight on a branch that should not bear it. The question is not only why it is small, it is also why it is not exactly zero. If it were absent, matter and radiation would tell the full story. They do not. Some almost empty essence now writes the future. An allied puzzle hums under that one. The present era appears special in a quiet way. The density of the gentle driver of expansion and the density of matter are of the same order today, even though they thin or remain constant at different rates. In the deep past, matter dominated. In the deep future, the driver will rule without contest. The crossing point happens near the present slice of cosmic time. This coincidence needs no audience to occur, yet the curiosity remains. Many minds prefer not to lean on chance when explanations are possible. The search for a cause that makes the crossing feel natural is itself a soft escalation of wonder. Early glimpses of young galaxies added another knot. Some infant systems appeared bright and massive sooner than naive models had forecast. When a telescope with patient eyes found such surprises, it did not overthrow the whole scaffold. It reminded everyone that physics in the first few 100 million years includes feedback, dust, star formation recipes, and black hole growth in a dance that is complex. Yet the very appearance of such large structures early asked whether the pace of assembly or the background expansion history needs fine work. Each revision brought models and observations closer. Each residual difference kept the conversation alive. The catalogue of possible answers broadened rather than narrowed. One family of ideas kept the framework of gravity intact and introduced a new component that changes gently with time. This field could roll slowly down a landscape of potential energy, offering a pressure that alters as the scale factor grows. Another family adjusted the rules of gravity on large distances, allowing curvature to respond differently to energy than Einstein's equations require. A third approach wondered if the inference from data was tangled, that hidden systematics in ladders and calibrations and selections were weaving a veil around a simpler truth. Each approach came with predictions that can, in principle, be checked by sharper measurements of redshift drift, by correlations between lensing and galaxy motion, by the detailed imprint of expansion on sound waves frozen into large-scale clustering. Horizons offered their own quiet unease. In a future that continues to accelerate, the sphere from which signals can ever arrive shrinks in co-moving terms. Remote galaxies already beyond a certain reach will never exchange light again. Their stories separate for good. The prospect is not tragic, but it is lonely in a graceful way. The night sky will empty star by star, as local companions merge and distant beacons fade into wavelengths too long to notice. The cosmic archive will thin. The idea that every question must be answerable yields to a gentler thought. Some answers are forever beyond any craft or signal. Mystery grows not only because data misbehaves, but because the fabric writes limits into what data can ever be gathered. There is also the delicate matter of time and its measure. When deep catalogues are compared, the very clocks used to label epochs must agree. Cosmic chronometers that use the aging of certain galaxies offer a direct sense of the tempo of expansion without leaning on full models. Their results sit next to other meters with mild tension. The pursuit of concordance becomes a discipline in itself. No single instrument or method can dominate. The deep calm of a shared picture must be built from many soft voices that learn to listen to one another's corrections. Even the geometry that looks flat within small margins carries room for subtle curvature. An almost flat universe could hide a gentle bend that shows itself only in the longest rulers. Distant standard sirens, born from gravitational waves with electromagnetic companions, promise to place fresh ticks on the scale. As they arrive, they may nudge the line one way or another. The possibility that new types of messengers will weigh in keeps the puzzle open, patient, and alive. The deepening is not a descent into chaos. It is the way a lake reveals hidden currents when the surface is glass. Small leaves drift apart in patterns that hint at eddies below. The leaves do not complain. They trace the shape of water that cannot be seen directly. The sky does the same. Slight shifts in brightness, small tilts in polarization, faint preferences in alignment, modest disagreements between one ladder and another. Each is a leaf. Together they mark currents in the law and in the content of the cosmos. The widening continues with serene confidence, and within that serenity the mind discovers new reasons to ask, with care, whether the rule is exactly as simple as it once seemed. Every refinement multiplies the places where surprise can hide. That is not a failure. It is a sign that understanding has grown sensitive. When knowledge becomes sensitive, it notices the soft tug of things that a rough picture would miss, a gentle acceleration that needs a name, a small mismatch between today's pace and yesterday's imprint, a quiet undergrowth in the clustering of matter, a nearly flat geometry that perhaps is not perfectly so, a horizon that draws borders no craft can cross. These are not alarms, they are invitations. The mystery deepens without raising its voice. It becomes more layered, more textured, more humane. It asks those who listen to slow their own tempo and let the complexity arrive without hurry. The quiet driver needs a name. One answer keeps the label simple. Empty space may carry a small, constant energy that does not thin as distances grow. In equations, it appears as a term that adds the same pressure everywhere, a pressure with a curious sign that urges the scale factor to glide faster rather than slow. This constant writes a line across cosmic history with unwavering patience. It does not clump, it does not flicker, and it does not listen to the chemistry of galaxies. If this is the case, the destiny of expansion is settled by a single number. The mind relaxes at the economy of it, even as it marvels that the value is so gentle compared with what quantum fields naively suggest. Another answer gives the driver a pulse. A light field, smoother than any fluid and spread across space, could roll slowly down a shallow landscape of potential energy. This field would act like a reservoir that drips rather than drains, changing its pressure as it slides. The effect on the scale factor would evolve with time. The rate of this change depends on the slope and curvature of the potential, features that theory can sketch and observation can constrain. Some shapes allow the field to track the dominant component for long eras before taking the lead. Others let it nap and then wake, or drift in a whisper that is almost constant. In each case, the field behaves gently, avoiding sharp forces or sudden turns that would disturb the delicate structure already formed. A bolder thought touches gravity itself. Perhaps the rule that binds geometry to energy bends slightly at great distances. The mathematics can be adjusted in many precise ways, each designed to keep the familiar checks near stars and planets intact, while letting the far universe relax differently. Some versions alter the function of curvature that enters the action. Others welcome a massive graviton, a particle of the gravitational field with a tiny rest mass that changes how perturbations travel. There are models that let gravity leak into additional dimensions at large scales, diluting its pull. Screening mechanisms must then step in, acting like filters that restore ordinary gravity in dense regions while allowing modifications to breathe in the thin outskirts. Each proposal is a sculpted bridge between laboratory certainty and cosmic freedom. There is a quieter possibility. The real universe is lumpy, with clusters, filaments, and voids, creating a web of inhomogeneity. The equations used to describe the large-scale averages assume that the smoothing of these features can be treated cleanly. Some have wondered whether the cumulative effect of many small folds and empty halls adds up to an apparent push, a back reaction that mimics a driver without introducing a new ingredient. Careful treatments often find the effect too weak to explain the full acceleration. Yet the question refines technique and deepens respect for how averaging works in a dynamic spacetime. On the observational side, the driver announces itself as an equation of state, the ratio of pressure to energy density recorded as a single letter. For a pure constant, that letter equals -1. For a rolling field, the value can hover near -1 yet drift with time. Measurements fold this drift into simple forms, allowing plots to compress the unknown into a small plane where data can draw contours. If the contours lock onto -1, the constant keeps its crown. If they tilt and slide, the field strengthens its case. The landscape of possibilities becomes a map that instruments can explore with more reach and less noise. The speculative branch allows the ratio to dip below -1. In this phantom regime, energy density rises as space expands. Such behavior leads to futures where bound structures unravel, not from violence, but from relentless stretching that overcomes every tie. The scenario has a softness that hides a stern fate for galaxies and planets, if carried to extremes. Theories that admit this behavior must face questions of stability and consistency. They sketch their architectures carefully, introducing safeguards in the microphysics to keep the whole from tearing itself apart in ways that ordinary quantum fields would not permit. Interaction adds another layer. The driver might whisper to matter or to neutrinos, trading energy in minute amounts that varies slowly with time. A small coupling would be invisible in laboratories, yet accumulate over cosmic ages, altering how structures grow and how the expansion bends. In such pictures, the dark components do not live in separate sealed rooms. They exchange news. The pattern of lensing and the details of clustering become translators of that news, allowing data to ask whether the growth of structure has been nudged off its otherwise smooth arc. The early universe may hold a clue in a brief episode where the driver carried a modest fraction of the total energy long before stars formed. Such early influence would slightly change the timing of acoustic peaks in the microwave background and adjust the pace of the later expansion without leaving large scars. If this hint proves genuine, it would suggest that the driver is not a fixed constant but a presence with history, one that fades and then returns with a calmer hand to guide the late glide. Extra dimensions tempt the imagination with quiet corridors that the eye cannot see. If space-time has more directions than the familiar four, mostly curled into tiny loops, or extending in ways that only gravity can explore, the large-scale law of attraction could relax differently than expected. Certain brain-world ideas let our visible universe live on a sheet within a higher dimensional space. The leakage of gravity into the extra volume can weaken its grip across very long distances. The result can mimic a gentle push without adding a new fluid. The challenge lies in satisfying all the crisp tests of gravity while letting the long-range modification appear only where telescopes, not torsion balances, can find it. A minimalist perspective keeps the equations intact and asks whether the inference is tangled by subtleties in the data. Distance ladders rely on calibrations that step from geometric anchors to variable stars to supernovae. Each step requires models of stellar populations, dust, and metallicity. Galaxy clustering and lensing require assumptions about bias, intrinsic alignments, and selection functions. Cosmic chronometers depend on precise ages for quiescent galaxies. Small uncertainties can lean together in a preferred direction. Work in this vein sharpens tools and holds the community to a high standard. It is not an effort to deny acceleration, but to weigh every ounce of assumption carried by the measurements. The sea of theories meets a coastline of consistency checks. A rolling field must leave imprints in the propagation of perturbations and sound speeds. Modified gravity must respect the speed of gravitational waves, measured from the choir of neutron stars when light and ripples arrive together. Screening must act without producing fifth forces that would have been caught in planetary data. Interactions must avoid instabilities and violations of well-tested conservation laws in small systems. Early influence must fit within the intricate pattern of peaks and troughs in the microwave sky. Each demand is a gate through which usable ideas must pass. Multiverse ideas appear at the far edge of speculation. If different cosmic patches explore different vacuum energies, then observers exist primarily in regions where the value allows galaxies to form. Under this view, the smallness of the constant is not derived from a unique calculation, but from selection among many possibilities. It is an answer that moves the question to a larger setting and invites a different style of reasoning. Some find calm in its breadth. Others prefer answers that root the value in a single mechanism within one universe. Either way, the concept reframes the mystery rather than ignoring it. There are also proposals that tie the driver to information, entropy, or holographic bounds, suggesting that what looks like a pressure is an emergent tendency of spacetime as a system that counts microstates. In such pictures, geometry and energy are not independent. They arise together from deeper bookkeeping, and the outward glide is a form of relaxation toward maximal simplicity. These ideas are young and precise, predictions are delicate, but they carry a poetic resonance with the overall sense of ease that the data imply. The path forward is practical. Measure the ratio of pressure to density more sharply across time. Trace how structures grow with multiple probes that cross-check biases. Time the arrival of light and gravitational waves from the same distant events to test distances in new ways. Monitor the slow drift of redshift over decades to watch expansion change in real time. Map polarization with finer resolution to sift early whispers from late echoes. Theories will remain as branches on a tree. Some will wither as the air thins. Some will leaf in fresh data and offer shade to thought. The central comfort is that the driver, whatever its nature, acts with restraint. It smooths rather than shatters. It invites attention rather than fear. The universe opens at a rate that gives stars time to burn and structures time to form, then adds a long horizon of quiet. The explanations respect that mood. Constant energy in emptiness, fields that idle and flow, laws that soften at distance, averages that hide a small collaborative effect, vast ensembles where selection writes the value, deep thermodynamic tendencies that surface as pressure. Each attempts to translate calm into cause. Each searches for a grammar that makes serenity lawful. The cosmos is patient, so the instruments that listen to it must learn patience too. Astronomers turn the sky into a laboratory by building rulers, clocks, and compasses that do not wear out. A ruler comes from sound frozen into matter. A clock is etched into the cooling of light. A compass appears in the way gravity bends paths. None of these devices sits on a bench. They are woven into the world itself and must be read with care. One ruler rests in the gentle memory of pressure waves that travelled through a hot plasma long ago. When the universe cooled enough for atoms to hold their electrons, those waves stopped and left a preferred separation in the arrangement of matter. Surveys now map that preferred spacing by counting how often galaxies appear at different distances from one another. The slight excess at a particular scale becomes a yardstick. As telescopes look out to earlier times, the apparent length of this yardstick changes in a way that depends on how space has stretched. It is a quiet method that asks only for positions and redshifts, then returns the tempo of expansion without the need for explosions or exotic light. Another tool uses the steady brightness of certain stellar deaths. Some stars end in thermonuclear flare, and their light curves carry patterns that allow their true brilliance to be inferred. By comparing that intrinsic glow with the measured glow, distance follows. Plot those distances against the softening of color with redshift, and a history emerges. Because dust and metallicity and selection effects can nudge the results, observers fold in corrections and run careful tests on the full chain of calibration. The work begins with nearby parallax, anchors brightness with pulsating stars, and lifts the ladder toward galaxies that host the flares. Space missions that measure angles with exquisite accuracy reduce the first rung's uncertainty. The remaining rungs must remain honest, so teams swap instruments, cross-check pipelines, and publish error budgets as if they were navigational charts. Gravity adds its own handwriting. Massive clusters and the web of matter reshape the images of more distant sources. On small scales, arcs and rings appear. On large scales, the shapes of millions of background galaxies are sheared by a tiny amount. From these shears, maps of mass arise, independent of light. The growth of that mass pattern with time responds to the expansion rate and to the rules that tie matter to geometry. By comparing the lensing maps to the distribution of galaxies, one can learn how luminous tracers relate to the invisible landscape they inhabit. The method is gentle. It relies on subtle statistics, careful modelling of atmospheric blurring for ground telescopes, and intensive calibration of detector quirks for space observatories. There is also a clock that measures expansion directly rather than through proxies. If a galaxy's redshift is measured again after many years, The drift in that number reveals a tiny change in cosmic tempo over the observer's lifetime. The signal is small, far below ordinary fluctuations, and so instruments must hold their stability like tuning forks that never fade. Spectrographs planned for this purpose will stare at the absorption lines of intergalactic gas for decades, turning the slow change into a detectable shift. Time itself becomes an instrument, and the universe is asked to show its hand in real time. New messengers expand the toolkit beyond light. When compact stars collide, their gravitational ripples carry the imprint of distance in the chirp of the waveform. If a companion flash in light or radio marks the host galaxy, the redshift is known. Each such pair becomes a standard siren, a direct distance measurement that bypasses the brightness ladder. Because the ripples move through space-time without scattering, their path is clean. A collection of these events will allow a fresh reading of the expansion rate and will test whether distances derived from ripples match those from photons. The choir of neutron stars and black holes will become part of the metronome. Structure that floats between galaxies adds another probe. Neutral hydrogen at radio wavelengths can be mapped not only as individual clouds, but as a blended background whose fluctuations track the underlying matter. This intensity mapping can sweep huge volumes quickly, giving access to many epochs. The characteristic scale of the ancient sound waves reappears in this radio texture, offering another version of the same ruler. Because the method uses long wavelengths, it complements optical surveys and widens the reach toward early times. The afterglow of the hot beginning remains a central witness. Its temperature ripples and polarization patterns have already set tight limits on the shape of space, the composition of the cosmic mix, and the size of the primordial seeds. Yet the testimony can become sharper. Future instruments will measure finer polarization and map the subtle lensing of that background into a blurred swirl. From that swirl, the distribution of mass at intermediate epochs can be reconstructed, tying the early blueprint to the later building. The consistency of this chain acts as a test of the whole picture. Nearby galaxies supply additional anchors. Some host water mazes in the disks that circle their central black holes. The orbital motion of these clouds can be measured with radio interferometers that synthesize a telescope the size of Earth. Geometry then yields distances without a ladder. Tip of the red giant branch stars add another anchor by offering a sharp feature in the brightness distribution of old stellar populations. These methods cross-check the brightness of pulsating stars and reduce the chance that unnoticed biases creep up the ladder to affect the distances of supernovae. Each anchor is a kind of humility, a reminder that independent paths must converge. Wide sky cameras that collect light night after night turn into machines for statistics. They find transient events that spike and fade. They trace weak lensing with billions of galaxy shapes. They map clustering over scales that reach a meaningful fraction of the observable universe. The cadence of their observations allows the same patch to be seen under many conditions, making it easier to filter noise from signal. With such depth and breadth, rare alignments and faint patterns become measurable, and the variance that once hid in small samples retreats. Cross-correlations are a subtle art. When a pattern in one field lines up with a pattern in another, the alignment can reveal a third ingredient. For example, if the gravitational potential wells that lens background galaxies also leave fingerprints on the microwave background through late-time effects, then combining those maps can lift the signal from the noise. The same is true when velocities inferred from gas scattering imprints align with the distribution of clusters, or when galaxy shapes are compared to the motions inferred from redshift space distortions. Each pairing extracts more information from the same photons. It is a quiet amplification achieved not by building bigger mirrors, but by letting different parts of the sky speak to one another. The practice of testing does not rest on single numbers. It lives in the curves that show how an equation of state might change with redshift, in the growth rate of structure as a function of time, in the relation between mass and light in halos, in the scale dependence of lensing signals. Instruments draw these functions with error bands that grow thinner as data accumulates. The goal is not to force a preferred answer, but to give fate less room to hide. If the driver of expansion is constant, the functions will fall into shapes that refuse to drift. If the driver evolves, or the law of gravity softens at large distances, small departures will appear in multiple panes at once. Every tool needs a guardian against false certainty. Dust reddens light in ways that can mimic distance. Detectors warm and cool. Catalogues inherit selection effects. Statistical methods can prefer symmetry where none exists. To keep the garden clean, teams inject artificial sources into their data streams to test recovery, blind their analyses to the final parameters until procedures are set, and repeat measurements with independent pipelines. They use overlapping surveys so that the same piece of sky is weighed by different hands. They publish not only the plots, but the covariants, the masks, and the code. The act of testing becomes a culture as much as a technique. The future brings instruments designed for long attention. Space telescopes will trace supernova light curves in the quiet above the atmosphere. Spectrographs on Earth will map 1/3 of the sky with a precision that lets the ancient ruler be read in dozens of slices through time. Gravitational wave detectors will grow sensitive enough to hear standard sirens from far epochs. Radio arrays will paint the hydrogen fog that once filled the dark between the first stars. Polarimeters will comb the microwave afterglow for the faint curl that inflation might have left. Over years and then decades, the plot of expansion will become a measured line rather than a sketch drawn between points. In this craft, the most relaxing fact is the approach itself. The universe is asked the same question, in many dialects. Distance is spoken by flares and by ripples, by radio maps and by microwave swirls, by the pattern of galaxies and by the small shear in their shapes. When the answers agree, calm deepens. When they differ, attention sharpens without haste. The tools improve, the tests repeat, the sky is patient, and the watchers learn to match its pace. The surprise arrived as a bend in a simple plot. Points on paper, each one a distant flare from a dying star, lined up against a curve that expected slowing. The curve came from gravity's familiar habit, a habit that gathers, breaks, and holds. The points refused to sit on that line. They drifted above it, faint by just enough to tell a different story. Faint meant farther than a decelerating universe would allow at the same color shift. Farther meant that the fabric had not only stretched, it had learned to stretch faster with time. The quiet agents of this finding were type Ia supernovae. They are thermonuclear endings that, after careful correction, shine with a dependable brilliance. Their light rises and falls with a rhythm that correlates with peak power, a relation that can be used to infer the true wattage from a light curve. Teams built this method into a craft. They measured the shape of each flare's rise, the pace of its decline, the tilt of its color as dust tries to redden the signal. They made K corrections to compare rest frame bands with observed ones. They trained algorithms to find the moment when the brightness would crest. Every decision was documented, every correction tracked, every risk of bias listed and tested. The result was a ladder that reached beyond the comfortable neighborhood of spiral arms and local groups. The observing nights were long and unhurried. Wide-field cameras swept patches of sky again and again, searching for a pinprick that was not there the week before. When a candidate rose, telescopes shifted to secure its spectrum and fix its distance by color shift. Photometry followed for weeks, a cadence designed to capture the full arc of the light. No single event could declare a verdict. Only a population could speak, and so the work leaned on repetition and patience. The reward was a set of candles that burned across a range of look-back times, each one a small clock stamped into the past. The language of interpretation was modest. Luminosity distance as a function of redshift became the page on which the story would be written. A universe that slows appears as a certain curve. A universe that glides with a constant pace appears as another. The data curled toward the line that belongs to a source of negative pressure, a component that pushes on the scale factor instead of pulling it back. The deceleration parameter, which had been expected to be positive in a matter-dominated epoch, appeared to cross zero at a moderate redshift. the sign turned, and the turn was the calm shock. What made the moment tender was not drama but coherence. An accelerated history resolved a quiet discomfort about age. The measured rate of expansion today, combined with a simple recipe of matter alone, had once made the clock of the universe too short for certain ancient stars. At a gentle pressure that sustains expansion, and the clock lengthened, the ages agreed. Globular clusters lost their protest. The sky, which had seemed to split attention between two incompatible timescales, learned to keep one time. The mathematics that supports this is not loud. The first Friedmann equation balances the squares of a rate against the density of ingredients and the curvature of space. Insert a term that does not dilute when space expands, and the right side retains a steady hand even as matter thins. The solution for the scale factor curves upward, soft at first, then smoother as the pushing term comes to dominate. No corner of the equation needs a trick. Gravity remains attractive for matter and radiation. The negative pressure of the new component acts not as an anti-gravity, but as a source whose equation of state shifts the balance in time. The observation did more than reveal a new term. It made a promise about the future. If the gentle pressure stays near constant, distant galaxies will slide beyond any ability to exchange light with this small patch. The observable region will become an island, edged by an ocean that keeps widening. The local group will merge into a single stellar city, while the rest of the grand web thins into signals too long and too faint to notice. The prediction is peaceful in tone. There is no wall, no collision, only a slow parting that writes serenity into the far horizon. That horizon writes a second promise into the canvas of time. The background glow that now rests at a few degrees above absolute zero will cool further. The colors will stretch until wavelengths exceed any antenna a future maker can build. Particles with mass will become more isolated in the cosmic sea, even as local structures keep their internal conversations alive. The arrow of time will still find its direction in entropy and in stellar life cycles, but the stage will grow spacious around the actors. It is a strange comfort to know that the largest fate foresees no sudden end. It sees only a long easing. The same data carried lessons about how matter was arranged during the period when the turn occurred. Gravitational potentials that deepen as structure grows should leave signatures on the background light through a late-time interaction between photons and evolving wells. In a world with acceleration, those wells do not grow without limit. Photons gain or lose a sliver of energy as they fall in and climb out. Cross-correlations between maps of the glow and maps of nearby mass reveal this slight effect. It is a measured nod from gravity to the new term, a faint handshake across epochs. Other checks joined in with the same calm discipline. Time delays between multiple images of lensed quasars, shaped by both the mass of the lens and the geometry of an expanding stage, drew circles around models that lacked the gentle pressure. The shapes of baryon acoustic features at intermediate redshifts leaned in favor of a late onset of acceleration, consistent with the turn suggested by the candles. Even the full pattern of ripples in the ancient glow, when interpreted with the added ingredient, settled into values for matter, curvature, and initial ripples that felt natural together. Within the discovery there lived a humility. Every correction applied to the flares came with doubts that had to be addressed. Could evolution of progenitor systems bias the brightness at high redshift? Could undetected dust mimic dimming? Could selection effects hide brighter events and leave dimmer ones to set the slope? Teams designed tests to weigh these worries. They compared supernovae in different host types. They modeled dust with multiple laws. They added near-infrared bands where dust matters less. They calibrated 0 points with overlapping instruments. The trend remained. The curve bent upward. The calm shock reshaped language. Words like jerk and snap, once casual in speech, found formal definitions in series that describe how the scale factor changes with time. The sign of deceleration turned out not to be the only news. The rate of change of that sign carries information about how soon the gentle pressure took hold and how firmly it rules. Observers began to speak of transition redshifts and of the redshift dependence of the equation of state, not to complicate a simple plot, but to let the sky answer a more nuanced question. Is the pressure constant in time, or only nearly so? The question sits still, clear and testable. At a human scale, the discovery had the character of a breath taken more deeply than expected. The universe did not sprint. It exhaled with a little more length as time went on. That extra length made room for everything that formed late, for the long arcs of chemical enrichment, for the assembly of spiral arms, for the slow education of planets. It made room for instruments to be built and rebuilt, for surprises to be confirmed. It made room for quiet thought. Calm lies not in the absence of change, but in the favouring of change that nurtures structure before dimming it with distance. In the end, the plot with its gentle bend became a touchstone. New surveys would add points at higher redshift, would add infrared candles less affected by dust, would find host galaxies with different histories, would seek standardizable events beyond supernovae. Yet the early realization continued to hold. The universe, once imagined to be decelerating under the exclusive rule of matter, revealed a softer law. It stretches, and with time it stretches more easily. The finding is both technical and tender. It is a line on paper and a feeling of ease that seeps into thought, a calm shock, and then a long exhale. Names arrive when the mind needs handles. Faced with a pressure that acts everywhere and resists thinning, scientists reached for a short phrase that could hold the unknown without pretending to solve it. Dark energy became that phrase. It does not describe a substance with taste or colour. It marks a behaviour. It says only that there is an influence not made of the familiar crowd of particles and fields that clump. The word dark means it does not shine. The word energy means it enters the equations as something that weighs on geometry. The pairing is modest. It keeps room for revision. Symbols follow the names, and symbols calm the conversation. A single letter can carry an attitude toward the sky. The vacuum term that keeps the same value at every point becomes a simple constant marked by a neat character. A fraction of the total budget carried by this term receives another symbol, the kind drawn like a resting horseshoe. When written this way, whole histories fit on one line. The line can be read by anyone who shares the grammar, and the grammar can be taught to students with a few curves of chalk. A ratio of pressure to energy density turns into a letter that sits between minus and plus. For ordinary matter, the ratio is near zero. For radiation, it is 1/3. For the smooth driver, the ratio clings to the negative. If it holds exactly to -1, the constant interpretation stands tall. If it wavers, even slightly, a field with a slow roll may be at work. This single number becomes a metronome. The drift of the metronome with redshift can be written as two more numbers, one for today and one that expresses how the value tilts with time. With such a pair, an entire family of possibilities is plotted as gentle contours on a plane. Names also live in the models that act as baselines. A picture that includes cold matter that does not interact with light, and a constant pressure that fills space gets initials. The initials are said aloud like a word, and soon the word means a world. That world is a set of parameters with best fit values and uncertainties. It is a graph of distances and growth. It is an age and a curvature that sits close to flat. The letters do not claim final truth. They declare a working language against which small deviations can be measured. The choice to name an idea shapes how questions are asked. Call the driver a constant and the questions lean toward why it is small and why it is not zero. Call it a field and the questions lean toward what potential it explores and whether it clumps at all. Call it modified gravity and the questions turn to how light and matter respond differently to curvature and how screening hides new forces near dense objects. Each name opens a corridor. Each corridor has its own tests. The act of naming is not decoration. It is a map. Even the quiet invention of acronyms carries weight. Projects and surveys adopt titles that spell short words. and those words become furniture in the room where evidence is debated. The furniture matters because it supports habits. A team that measures shapes of galaxies night after night thinks naturally in shear and convergence. Another team that watches stellar deaths for months thinks in light curves and color terms. When they meet, the names translate patterns from one dialect to another. The translation is where confidence grows. There are names for the ways the driver might behave when space is thin with matter or when the universe was young. Early influence becomes a phrase with soft edges. Tracker fields and thawing fields acquire labels that speak of motion along gentle slopes. The sound speed of perturbations becomes a parameter, named and placed in equations to see whether the driver ripples or remains placid. If it ripples, it might leave small imprints on the clustering of galaxies. If it does not, it hides like a mist that adapts instantly to changes in pressure. There are names that invite caution. Phantom regimes with ratios below -1 carry a hint of danger in how they evolve. Kinetic alternatives carry names that emphasize the form of their energy. Unified pictures that attempt to blend the behavior of dark components into one fluid adopt titles that recall gases and exotic equations of state. These labels live at the edge of comfort. They remind the reader that theory can roam and that observation must remain the guide. A different set of names ties the driver to deep principles rather than new ingredients. Hints of the holographic view, where areas count as if they were volumes in a more cryptic bookkeeping, inspire titles that evoke screens and bounds. Entropic drives and emergent gravity earn phrases that point to hidden microstructure. Such names are not verdicts. They are bookmarks in a library that may one day hold a full account. Until then, they help minds remember where the open shelves are. The past gives names that are simple and durable. The prime actor of gravity has a name attached to the person who wrote the rule, but the rule has become larger than its author. The modern constant of empty space takes a letter from the earliest equations that allowed stillness. The reuse of the symbol is a kind of reconciliation. What once kept the cosmos from moving holds a new meaning as a soft engine that lets it move more freely. The continuity of letter and the shift in interpretation sit together without tension. The act of fitting data invites yet more compact phrases: figures of merit, volumes in parameter space, tension indices, and concordance tests reduce complex comparisons to numbers that can be printed in a line. These names make it easier to track progress and to see where different measures clash or agree. They also demand restraint, because compression hides nuance. A figure can rise while a subtle bias grows. Attention can appear large, while the assumptions that tie two measurements together remain under debate. Good naming is honest about the slimness of a line drawn through a forest. Language for the future appears as well. Standard sirens already sound like a promise. Redshift drift already reads like a clock. Intensity mapping murmurs of faint structure. Each phrase is quiet and practical. Each says what will be done without fanfare. Because of that simplicity, they reassure. They make clear that the unknown is being met with plans that rely on endurance rather than force. There is poetry in the smallest notations. A dot above the scale factor is time. A prime on a potential is slope. Curly letters stride across the page like rivers, carrying densities and pressures in their flow. Plain letters hold constants as if they were stones placed to build a bridge. These marks do more than calculate. They soothe. They tell a reader that the path is shared, that the work is incremental, that the unknown is allowed to remain unnamed until its behavior insists on a specific title. The habit of naming also protects humility. Dark does not mean unknowable, only unlit for now. Energy does not mean a fuel to be tapped, only a contribution to the right-hand side of an equation that keeps its own counsel. Constant does not mean forever, only for as long as measurements refuse to betray a drift. Field does not mean a harvest. It means a function with slow motion. Gravity does not mean a single law from which no deviation is possible. It means a tested framework with room at the edges for careful change. The names remind the mind to keep a light touch. In quiet moments, The names are repeated almost like a litany: constant, field, pressure, ratio, contour, distance, drift. The repetition creates order. Order slows thought to a pace that matches the subject. The expansion of the universe is not a racket. It is a process that can be carried around in a handful of symbols and words, each chosen to avoid claiming too much. With these handles, the conversation remains generous. It makes space for new evidence to step in. It lets old intuitions step back. It turns a vast mystery into a set of questions that can be shared without heat. There are places where the grand drift slows to a murmur. Gravity arranges such places with a patient hand. It gathers matter into halos that carry a memory of collapse and a promise of stability. Inside these halos, orbits weave and cross until motion averages into a calm crowd. The expansion of space continues outside, but within these regions, the dynamics belong to the local mass. The quiet is not silence, it is balance. A galaxy shows the pattern clearly. Stars circle a center that no one star occupies. Their speeds settle into a profile shaped by a dark halo, whose particles rarely meet, yet collectively bind the light. The virial theorem tells the story in a single relation. Kinetic energy balances half the magnitude of potential energy. When this balance holds, the system rests in a statistical peace. Encounters still occur, but they are not riots. The orbits share a truce that lasts longer than any star's life. The scale of this truce is small compared to the sweep of the sky, yet within it the mind finds relief. Here, expansion is a rumour carried on the edge of the wind. Clusters of galaxies raise the lesson to a grander scale. Hundreds of spirals and ellipticals move within a shared well, their paths broadened by the group's mass. Hot gas fills the void between them, glowing in X-rays with temperatures that testify to deep gravity. The gas does not escape, because the cluster's potential prevents it. Collisions between clusters build larger basins with shocks that ripple through the plasma and faint streams that draw between galaxies. Even so, the whole assembly can be treated as an island where the tide of the universe laps weakly at distant shores. There exists a radius for such islands, a boundary where inward pull ties with the outward flow. Inside this turnaround edge, matter has shrugged off the general drift and follows the local choreography. Outside, the background expansion carries objects away unless a new invitation to fall is offered. The radius is not a wall, it is a condition. At this boundary, a particle at rest feels the sum of two trends reach a draw. The draw favours the island if the particle is close. It favours the sea if the particle is far. The quiet of bound structure lives inside this invisible contour. On still smaller scales, the pattern repeats. A planet circles a star. The star nestles into a spiral arm. The arm belongs to a disk. The disk sits inside a halo. Each level adds neighbours and extends the pool where orbits find their compromise. The expansion does not pry apart the Earth and the Sun, because the local curvature carved by the Sun dominates that patch of space-time. The same is true for the bonds of molecules and the grip of a rock on a riverbed. The drift of the universe operates where gravity has not already claimed authority. Authority at small scales is old and firm. Filaments thread between the islands, long lanes where matter flows toward nodes that will become clusters. These strands are not still. They carry slow traffic, guided by gradients in the potential landscape. Yet even here there are pockets where the rush abates. Subgroups assemble. Dwarfs gather around larger hosts. Lenses form that bend the light of background galaxies into soft arcs. The filament is a corridor, but the way stations along it become havens in their own right. The intracluster gas explores a different form of rest. It reaches hydrostatic equilibrium when pressure gradients balance gravity. Temperatures become maps of depth. Where the well is deep, the gas is hot. Where substructures linger, the gas ripples, then settles. Feedback from central galaxies, jets, and outflows prevents the gas from collapsing too eagerly. This regulated quiet allows star formation to proceed in measured bursts, instead of unsustainable cascades. A long-lived balance replaces flashes that would exhaust the fuel. As the universe ages, acceleration affects which scales can still assemble. Growth slows on the largest lengths because the gentle push resists the deepening of far-flung potentials. Structures that had already turned around continue to relax. New giants form less easily. The cosmic web freezes in slow motion. This freezing is not a sudden halt. It is a long tapering that privileges maintenance over invention. Islands refine their interiors, while the sea beyond grows wider and smoother. Within islands, time stretches differently than it does across the void. The density is higher, so clocks tied to local dynamics tick to a nearby rhythm. A merger between two galaxies takes hundreds of millions of years, yet it is brisk compared to the time it will take distant companions to drift beyond the reach of any light from the island. The hierarchy of motion turns into a hierarchy of calm. Quick dances settle into one galaxy. Slow drifts define the cluster. Very slow partings thin the web. One can hold all three tempos in mind at once and feel a layered quiet. Tides shape the edges of this piece. A dwarf that ventures near a giant feels its outer stars loosen. Streams appear, faint ribbons that record the path of the encounter. These streams are not signs of turmoil. They are signatures of a system finding a new equilibrium after a gentle pull. Over time, the debris blends back into the halo, adding to the smooth profile that gives the main galaxy its extended mass. The process knits the island tighter, even as it rearranges the stitches. Local flows near groups and clusters carry a lesson about cooperation. Galaxies fall along preferred directions into the deeper wells. Their peculiar velocities, the deviations from the general drift, are coherent over many millions of light years. The coherence comes from shared history. Gravity remembers, and its memory shows up as alignments and as bulk motions that respect the shape of the surrounding landscape. Yet the respect remains bounded. Once a system crosses the turnaround, local rules dominate. The global tide falls to a background hum. There is a quiet future in store for such islands. Neighboring galaxies merge until one luminous body holds the stars of many. The remnant is rounder and deeper, a beacon in a dark that grows darker. Smaller companions continue to rein in on elongated paths, adding shells and ripples to the halo. Gas cools more slowly as the background thins and as heating from central engines keeps a steady floor. Star formation fades, not in a collapse, but in a gentle winding down that respects the finite reservoir. The island becomes a city of old light, serene and heavy. Equilibrium never means immobility. Orbits precess, bars rotate, disks thicken, black holes feed on gas clouds that stray too near, then starve for long intervals. Cosmic rays thread through magnetic fields. Dust settles, moves, and settles again. Each motion is part of a conversation that keeps the energy ledger balanced. The miracle is that the balance holds across 10 orders of magnitude in scale, from the gesture of a planet to the aimless wander of a star in a cluster halo. A person standing under a clear night feels this balance in a way that bypasses equations. The fixed constellations ride a rotation that returns them nightly. The Milky Way arches as a pale river and carries an implied promise that its form will persist longer than any city or mountain. Even if the grand drift is tugging far realms apart, the close bonds do not slacken. The sky over one lifetime is a faithful mirror of the island's calm. The wake of acceleration writes one last grace into these harbours. As the horizon withdraws, external tides weaken. Encounters with truly distant masses become rarer. The island is left more fully to itself. It perfects its balance, untroubled by the long reach of neighbours that will soon be beyond communication anyway. The serenity that results is not isolation in the cold sense. It is autonomy. Within the boundary, gravity's law is enough. There is hospitality in these islands. They gave time for planets to cool and for chemistry to toy with complexity. They gave time for stars to live long, red, and quiet lives that favor stability in their retinues. They gave time for observers to arise and point instruments outward without fear that the stage would change faster than understanding could keep up. The expansion may be the general rule, but the islands are the places where that rule grants refuge. In them, the universe proves that wideness and shelter are not enemies. Listening well begins with quieting the room. Observatories learn this discipline with hardware that calms its own heartbeat. Mirrors are polished to figures so smooth that starlight lands without a ripple. Cameras are cooled until thermal electrons slow to a crawl, and the noise they make is less than a whisper. Microwave receivers sit in cryogenic chambers, where temperatures drop close to the purest cold a laboratory can sustain. At such depths, a change of a few millionths of a degree becomes audible to circuitry tuned like a violin string. When the instruments fall almost silent, the sky's murmur speaks. The murmur is faint, so its measure depends on repetition. A patch of darkness is not seen once and left alone. It is revisited on a cadence that turns chance fluctuations into averages and averages into signal. Dithers slide the image by small offsets so that defects in detectors do not masquerade as galaxies or lensing shears. Drift scans let the sky paint its own stripe while the telescope holds still, trading mechanical motion for Earth's rotation, a swap that buys stability with patience. Each strategy is a way to say the same thing. Let time smooth the roughness that equipment and atmosphere insist on adding. Clarity follows calibration. Every photon must be weighed against standards that do not change their minds. For optical work, spectrophotometric stars provide anchor points on the scale of brightness and color. Laser frequency combs draw evenly spaced lines across spectrographs, locking wavelength to atomic precision. At radio frequencies, artificial noise sources of known strength are stepped into the signal chain so that gain can be tracked as night air cools and warms the electronics. In the microwave, blackbody loads at controlled temperatures set the absolute scale. Calibration lamps, metrology grids, and stable standard fields turn the sky from a canvas of marvel into a chart with marks that can be checked. The shape of light matters as much as its count. Point spread functions, the tiny blurs that telescopes paint onto every star, are modelled with care. A misstep here leaks into every measure of galaxy shape, and thus into every inference about the bending of light by mass. Engineers map these shapes across the field, allow for breathing in the optics as temperature shifts, and teach algorithms to correct the blurs without inventing features that were never there. The choreography is delicate. It is also necessary, because a whisper of asymmetry in a billion distant galaxies is the clue that gravity leaves behind. Distance belongs to color and spectrum, but distance also hides in probability. Photometric redshifts estimate remoteness from broadband colors when spectra are hard to win for all sources. Hierarchical models treat every galaxy as both an individual and a member of a population, letting priors on the distribution of types and ages tame the uncertainty for each one. Spectroscopic subsets serve as tutors, correcting the biases in the wider school of photometric estimates. The approach admits ignorance openly, then reduces it with statistics that fold many weak clues into a sturdier whole. The murmur grows clearer in combinations. Stacking takes many faint things that cannot be seen alone and overlays them in a common frame so that the shared signal rises above noise. Cross-correlation joins maps that arise from different physics. If a subtle imprint in the microwave background aligns with the distribution of clusters in optical surveys, the alignment speaks of aging gravitational wells. If shear fields from lensing align with galaxy density fields, the degree of alignment tells how light traces mass. Each pairing acts as a translator between languages, drawing meaning from patterns that neither map could reveal alone. Simulations become rehearsals for the sky. Computers evolve universes whose ingredients, forces, and initial ripples are chosen at the start. The growth of structure, the behavior of gas, the formation of stars, the feedback from black holes, all are modeled with recipes that aim to be faithful. From these virtual skies, mock catalogues are made and pass through the same pipelines that treat real data. The exercise exposes biases, quantifies completeness, and teaches analysts how to recognize tricks that selection effects can play. When reality arrives, the rehearsal has already taught the company where to stand. The discipline of error bars is a form of ethics. Uncertainties are not decorations on plots. They are part of the message. Teams build covariance matrices that capture how errors in one bin lean on errors in another. They blind their analyses so that the final parameter values remain hidden while methods are tuned, guarding against the subtle urge to stop when results look familiar. Null tests multiply, each designed to produce nothing if the system is clean. Rotate galaxy shapes by 45 degrees and lensing should vanish. Split the data by night and by instrument and the cosmology should hold. Subtract fields observed back to back and the difference should be noise. When a null test refuses to be null, the pipeline learns humility and tries again. A clock can be built from spectra that refuse to drift. Ultra-stable spectrographs lock to the heartbeat of atoms and look for a change in redshift over human decades. This sand grain of a signal requires instruments that remember yesterday with uncanny fidelity. Temperature control, pressure control, fiber scrambling to average illumination across the slit, all are acts of devotion to sameness. The reward, anticipated still, is to watch the universe change speed in real time, the most literal possible measure of expansion. Standard sirens add a new tone. Gravitational waves, immune to dust and indifferent to magnetic fields, carry distance in their waveform without calibration to a standard candle. When a counterpart in light pins down redshift, a single event sketches a point on the distance redshift plane. Many events draw a curve. Because the physics of the chirp is clean, the chief labor lies in localizing the host and learning its motion. The choir of binary mergers turns into a metronome whose beat is written in space-time itself. Microwave polarization asks for monastic quiet. The curl component that would betray primordial ripples is so faint that atmosphere, ground pickup, and instrument polarization must be tamed by design. Polarization modulators spin to separate sky signal from instrument effects. Baffles and shields reduce spillover. Site selection chooses high, dry air where water vapor does little to twist the signal. Foregrounds from our own galaxy are mapped at multiple frequencies so that their spectra can be fit and removed without scraping away the signal beneath. The goal is not a single dramatic detection, but a bounded limit that closes doors on some early histories and leaves others standing. Catalogues become atlases. Each source in an image is not just a dot, but a vector of properties with uncertainties and flags. Provenance is recorded. Which night, which detector, which version of the pipeline. Reproducibility is treated as a virtue. When a result is published, the code and masks and selection functions go with it. The community becomes an extended instrument, checking, repeating, and improving. Iteration replaces proclamation. The murmur grows louder not because the sky changes, but because many ears, listening together, learn to discern it better. Future work stretches the meaning of patience. Some projects plan for 10 years of constant watching, a baseline long enough that rare alignments and slow drifts come into view. Others invest in depth over width, staring at a tiny field until it yields galaxies so faint that their light left when the first heavy elements were young. Surveys with millions of spectra aim not for romance but for completeness, building three-dimensional maps that track the growth of structure slice by slice. Radio arrays prepare to map neutral hydrogen, not as bright points but as a textured background. Each choice is a style of listening. Through all of it runs a single habit. Measure the same thing in several ways. Distances from candles, from ripples in gravity, growth from shears, from clustering, from velocities. Each channel is imperfect alone. Together they corner truth. Their agreement brings ease. Their disagreements bring attention without hurry. Patience is the law, because the universe speaks softly. The tools that honor that softness are the ones that turn a vast, low hum into knowledge. Every view contains a quiet edge. Not a wall, not an end. An edge made of time. The universe sets this boundary with the speed of light and the length of its own memory. Look out from any galaxy, and there is a farthest reach from which light has had time to arrive. That reach forms a bubble of history called the particle horizon. Its radius is not set by a ruler laid in space, but by how long the cosmos has been transparent and how the fabric has stretched while light crossed it. Photons that left their sources when atoms first formed a neutral fog are the oldest messengers of light that can be seen. Their glow arrives cooled into microwaves, a skin of first visibility that wraps the sky like frost. Beyond that skin, light was trapped by electrons and protons chatting incessantly. The horizon marks the end of that chatter. A different edge lives deeper in the future, an event horizon that depends on what the expansion intends to do. If the widening keeps easing faster and faster, there will be distant regions from which no signal, launched today or tomorrow, will ever reach the local shore. This horizon is not the same as the particle horizon. One records a farthest past that can be known by light. The other records a limit on what can ever be known from beyond a shifting boundary in the future. The first is a diary. The second is a promise written in faint ink. Together they show that visibility has both memory and fate. Another characteristic scale sits between the two and changes with time. It is the distance at which recession speed equals the speed of light. It is not a hard boundary. Photons can cross it, slipping inward from realms that once receded superluminally because the scale factor does not stand still while they travel. The crossing is possible when the expansion rate declines. In a world where a gentle pressure dominates, that rate tends toward a constant, and the characteristic distance approaches a fixed value in physical units. A photon that has not begun its trip by a certain epoch may never beat the stretch to arrive. The edge behaves like a shoreline, slowly moving outward, while boats try to row in. These horizons are drawn by light cones, the tilted regions in space-time within which cause can influence effect. The tilt depends on the scale factor. Early on, when everything was hot and dense, distances grew quickly compared to the age. Light cones were narrow in the time direction. As the cosmos cooled and expansion slowed, they widened. In an accelerating era, the cones lean again, writing a wedge in which far events fall outside possible conversation. The geometry sets the grammar for what can be known, and the grammar is mercifully clear. The numbers give shape to the calm. The radius of the visible past in co-moving terms spans tens of billions of light years. This is not how far those sources are now in physical distance, which is larger because space grew while their light traveled. The event horizon, if acceleration holds, encloses a scale of a few tens of billions of light years in the same co-moving sense, a smaller bubble than the one that contains the past. That mismatch carries a gentle lesson. More of the world can be remembered than can ever be reached. Memory is larger than possibility. Borders written by horizons affect how signals age. Photons climbing the swelling background lose energy to the stretch of their wavelength. Those sent from near the edge arrive with colors dragged deep into the red, dimmed to a whisper. The softening is not a failure, it is an accounting of how long they have been at sea. The same fate awaits future signals launched from us toward distant shores. They will be thinned and cooled until they become part of a background too faint to notice. Communication across great gulfs becomes a poem that fades line by line. There is warmth even in edges. In a space-time that glides toward a stable rate of expansion, the event horizon behaves like a thin skin with a temperature assigned by the rate itself. This is not heat in the everyday sense. It is a quantum whisper that says horizons are not empty, that they carry a faint glow in principle, a balance between the geometry of space and the accounting of information. The value is exquisitely small, impossible to feel with any device that could ever be built. Yet the concept is a reminder that boundaries in general relativity and quantum theory are not just lines on a diagram, they have character. Other messengers draw their own horizons. Neutrinos, which slipped free when the world was still a teeming plasma, carry a record from a deeper past than light. Gravitational waves, ripples in the very fabric, can pass through epochs that were opaque to photons. Their horizons sit differently in time because their interactions are rarer. The potential to hear further back than can be seen adds a new shoreline on the map. It says the ocean is not uniform. Different boats can ride different currents. The notion of an apparent horizon adds a layer of subtlety. It is defined locally, a surface where the outward-pointing light rays neither advance nor retreat in area for a moment. In a dynamical universe, this surface can differ from the event horizon. The distinction matters in simulations and in theoretical thought, because one boundary responds to immediate conditions while the other depends on global destiny. The contrast is like the difference between a fog bank that hugs a ship and the far line where sea and sky meet. Edges shape structure. In a universe that accelerates, the largest scales freeze. Perturbations that would have grown if gravity had been given more time stop deepening. The web remains, but its songs slow to a hum. The thickness of the visible slice thins as more of the distant score moves beyond the future horizon. Observers who come late in the long evening will see fewer galaxies and weaker imprints of large-scale flows. Their atlases will be simpler, their reconstructions of history more difficult. The sky will still be true to itself, but less generous with detail. The notion of cosmic variance becomes a gentle restraint. Even with perfect instruments, certain questions cannot be answered with absolute precision because there is only one sky to sample. The largest patterns on the microwave background are a single draw from a cosmic lottery. Horizons set the number of independent patches available to measure. The finitude of that number is not a flaw. It is part of the kindness of reality, a nudge toward modest expectations. The redshift of distant galaxies drifts with time in a sign that depends on their distance. Some will seem to creep to redder hues faster, others will inch toward less extreme red with the passing of centuries. This drift is tiny, but it encodes the changing slope of the expansion. It is another way horizons register themselves in measurable terms. The edges that feel abstract enter the ledger of possible observation as a slow ripple in color. Shorelines also calm the imagination that worries about edges that hurt. There is no outer rim where matter stops and emptiness begins. Every point sees itself as a center by symmetry, and every point measures horizons that belong to its own history and future. This democracy removes fear from the word boundary. The limit on sight and on talk is not a fence erected by a neighbor. It is a curve traced by light cones opening from a single world line. The limit is intimate. In all of this there is a final soft lesson. Boundaries can soothe. Knowing that there is a furthest past to see and a furthest future to be heard does not diminish the scene. It frames it. It lets a finite mind hold an infinite setting without losing balance. The view recedes in a way that feels natural, like a tide that draws back to reveal a longer beach. The ocean does not end. The eye learns where the day allows it to rest. The equations sketch a serene destination. When matter thins and light grows cold, a simple space-time comes forward and holds the stage with unhurried grace. It is a geometry where distances grow at a steady fractional rate, where the curvature is soft and unchanging, where every direction looks the same to patience. This limit is called a de Sitter world. It is not a palace of fireworks. It is a quiet room of perfect proportion. In that room, expansion no longer struggles against the pull of clusters or the tangle of filaments. The gentle pressure that fills space becomes sovereign, and the scale factor glides with constant ease. Stars carry the first part of this future on their own clocks. The blue giants spend their fuel in brief brilliance and fade. Yellow stars write longer chapters and then join the company of dwarfs, white and red, that persist across eons. The smallest red dwarfs outlast empires of time, burning with a thrift that is almost devout. They give a long twilight to the cosmos, a slow glow during which planets circle and chemistry hums. In the end, even these frugal fires dim. New stars form less often as gas is locked into remnants or heated beyond the point where collapse is easy. The cities of light become older, their birth rates slow to a drift and then to a memory. Galaxies continue their private work while the large scale glides away. Local mergers turn spirals rounder. Black holes grow by sips and then by long pauses. Rings and shells whisper of old encounters. In clusters, orbits relax into a quiet crowd. Yet the horizon keeps its promise. Beyond a certain reach, signals will no longer arrive. The night becomes a neighborhood. Far beacons that once anchored navigation have moved into a red so deep that no instrument can draw them back. The observable world shrinks in meaning even as the physical universe swells without limit. The paradox is gentle. What can be known becomes simpler, while what exists keeps opening. Temperature carries the message with restraint. Background photons stretch until their energy falls below any practical measure. A thin quantum warmth is assigned to the horizon itself, a number set by the steady rate at which space grows. It is a concept more than a comfort, a reminder that geometry and quantum fields converse even in silence. The value is vanishingly small, but its presence says that boundaries are not empty of character. They glow with a meaning that never needs to be seen to be real. The black holes that once lit quasars now take their long turn as anchors of time. They swallow stars that stray and streams of gas that wander. Accretion disks flare, then the larders run thin. Over unimaginable spans, the holes themselves release their mass in a soft rain of quanta. The radiation is physics made patient. Large holes take longer than the present age of the cosmos, far longer. They are the last storytellers among objects, fading not with a shout, but with a breath spread across eras that dwarf galaxies and clusters. When they finish, the stage is left to lighter remnants and to particles that rarely meet. Speculation touches the fate of matter itself. If certain processes break the loyalty of protons to permanence, then atomic building blocks decay with a half-life so long that it reads like a myth. Should this occur, the gradual unmaking adds another layer of ease to the final canvas. Bound structures turn to lighter particles that stream through a space too wide to bring them back together. Even if protons endure, the cooling and expansion guarantee that collisions grow fewer, reactions rarer, and the dance more like a slow drift. The deep future is sometimes imagined as a desert, yet its quiet is full of texture. A single galaxy that has merged its neighbors can be a city of old stars, dim but numerous, their orbits smooth in a halo that remembers every encounter as a profile rather than as a scene. Stellar remnants share the space with planets gone dark. Occasionally, a small body wanders too near the central mass and sparks a brief episode of light. Then the slow routine returns. The rhythm of calm does not forbid punctuation. It only sets the measure so wide that punctuation becomes a grace note. At the scale of the whole, the de Sitter geometry is a balm for calculation. The curvature is constant. The equations simplify. Light cones settle into shapes that make limits clear. The event horizon holds steady in physical size, a fixed distance beyond which events are forever excluded from conversation with the local observer. The constancy acts like a promise that the rules will not change again. It is not a promise written in stone, because physics keeps room for deeper insight, but it is written in a language that present knowledge reads as durable. Entropy keeps its slow count. Processes explore the available states. In local places where gravity dominates, entropy grows by mixing or by collapse that yields new surfaces with area to count. On the largest scales, the horizon itself holds most of the ledger, a vast store of potential configurations tied to that simple area. The arrow of time remains a direction, though its markers are subtle. No great fires reorganize the world. Instead, mild rearrangements accumulate, and the book of possibilities fills its pages in small script. Questions that live at the edge of thought are invited to sit down in this calm. If the vacuum is truly stable, then the de Sitter glide continues without interruption. If a deeper state exists, hidden beneath, A transition could occur through a quantum tremor. Such a thought is not a prophecy, it is a map of possibilities. The serenity of the known is not undone by the acknowledgement of the unknown. The scene remains one of ease, with surprises, if they come, arriving on scales of time that rescue them from any demand for drama. The mind that contemplates this future often returns to nearby scales to keep its balance. Planets have seasons. Stars have cycles. Galaxies evolve on spans that an attentive imagination can still grasp. The far limit is useful not as a place to live, but as a horizon that gives orientation. Knowing that the equations favour a smooth ending helps interpret the middle chapters. It tells why the web of structure freezes in slow motion, why new giants are rare, why late-time messages fade. It gives context without insisting on despair. A universe that becomes De Sitter-like is one that protects local stories. Within islands, gravity writes long chapters that are nearly self-contained. Outside, the fabric continues to widen with a steadiness that forgives delay. Discoveries can be made at leisure, instruments can be built, used, and rebuilt across generations. Knowledge accumulates in small stones rather than in avalanches. The overall tone is one of endurance rather than urgency. There is a kindness in this fate for memory. Though the visible atlas shrinks, records and models can hold the vanished regions as reconstructions. Light that has already arrived can be kept, studied, and woven into histories of the time when the sky was crowded. The calm future does not erase the past. It preserves it in a library that drifts with its own gravity, warm within a circle of stars that will one day dim together. Even in the late, quiet, chance meetings can occur. Long-period orbits send remnants through halos, where weak tugs add and subtract over aeons. A capture here, a gentle collision there, a flare that reminds the dark of a former age. Memory and present converge in these small events, like sparks that rise from a cooling fire and fall without threat. The background remains unchanged. The ease continues. The closing image is not of emptiness, but of spaciousness. A sky with fewer lights, a geometry with steady breath, horizons that rest at known distances, physics that whispers rather than shouts. The figures that describe it are simple enough to be held in a few lines. The feeling it gives is the rare calm of a story that knows how to end without ending. It continues into a softness that needs no audience to be complete. Meaning rarely arrives with a cymbal crash. It comes like starlight, crossing long distances, softened by the journey, easy to miss unless the eye has learned to relax. He watches the sky lengthen and feels a change in his own posture. The lesson is not that size dwarfs the person. It is that scale teaches a method. The universe stretches without hurry. It keeps its promise of patience even while forging stars, building galaxies and sketching horizons. A human life can borrow that rhythm. He begins with time. On the largest stage, clocks are not tyrants, they are guides. Growth and cooling set their own cadence. Nothing essential is rushed. If he arranges his days with the same generosity, tasks become tides. Work rises and falls. Learning deepens by revisiting. Relationships widen by gentle attention rather than sudden force. He notices that when he hurries less, more fits. The hours are not longer, they are broader, as if space has been given to each moment. In that space, care takes root. He considers comfort. Expansion is not a battle against borders. It is a steady giving of room. He can practice that with others. A conversation becomes an enlargement of shared fabric if he listens until the words have lengthened to their natural size. A disagreement remains bound like a local structure, while the field around it grows enough to hold both views. He does not need to win to move forward. He needs to make space. The calm that follows is not surrender. It is competence in the geometry of grace. He turns to humility. There is no favoured centre in a sky that looks the same in all directions on great scales. He learns to live without a throne. The absence of a privileged seat is not an insult. It is a relief. He need not oversee every scene. He can be a local orbit in a vast system that carries order without him. The relief spills into kindness. When he forgets to be central, other lives come into better focus. Their lights are not threats. They are neighbours whose stories can be honoured without comparison. He thinks about strength. Gravity gathers, binds, and protects small regions. Expansion offers freedom and distance. They coexist. He can do the same. In his home, he can be strong enough to hold, and in his dealings with the world, he can be spacious enough to release. He can draw boundaries that keep harm from entering and keep his own tides from flooding others. The balance is not fragile if it is built with the same steady arithmetic that lets stars and clusters persist inside a widening sea. He looks for a way to read change. Light holds the history of motion in its colour. Redder means farther and older. In his own choices, he can track the drift by tone rather than by motion. Speech that harshens tells of compressed time and crowded thought. Speech that softens indicates room enough for truth to unfold. He can tune his life like a spectrum, adjusting the bandwidth of attention so that meaning does not blur into noise. He studies edges. Horizons do not scold. They set the horizon of knowable past and the limit of future contact. He can accept the same kind of boundary in his plans. Some tasks will never be finished in his lifetime. Some questions will resist an answer. Rather than chafing at that edge, he can let it shape a humane ambition. He can focus on work whose completion matches the shape of his days, and he can entrust longer arcs to hands he will never shake. The peace that follows is not defeat. It is alignment. He remembers that quiet can hold a complex story. The background glow is smooth, yet it contains the memory of ancient sound. In his own quiet, depth can exist that is not dramatic. A simple routine can carry harmonics if he attends. Morning light across a table, the regularity of a walk, a meal prepared with care, all can hold the trace of older songs. He does not need constant spectacle for life to be full. The fullness is in the fidelity of small waves that return on time. He practices patience in measurement. Astronomers stack faint signals for years to draw them out of noise. He can do the same with virtues that do not announce themselves loudly. Trust stacks in small acts kept. Courage stacks in small fears faced. Curiosity stacks in small questions, asked without shame. Over time, the signal rises. He becomes legible to himself. The person he sought to be appears not in a single event, but in a contour drawn by many points. He revises his idea of progress. The largest structures freeze as acceleration takes hold. That does not mean nothing happens. It means invention shifts from magnitude to refinement. He can let his craft evolve the same way. Early years may build breadth. Later years can polish depth. The shift is not stagnation. It is respect for the stage. He does not chase size for its own sake. He searches for elegance, the cleaner sentence, the truer line, the quieter kindness that lasts. He learns to value limits. A future horizon means some messages will never be received. He can honour friendship and love within the reach that exists, free of the ache for an unreachable completeness. He can write letters knowing that some will never be answered and still find meaning in the writing. He can send care without demand for echo. The act becomes its own arrival. Expansion has taught him that separation need not be loss if what is near has been tended well. He cultivates a gentler ambition for knowledge. Cosmic variance tells that certain answers will always come with uncertainty because there is only one sky to sample. He translates this to the inner world. There is only one life to measure. Some traits will remain estimates. Some motives will be seen through frosted glass. He can let the not knowing be part of the truth he carries. This acceptance does not dim effort. It keeps effort honest. He finds a model for endurance. The calm driver of expansion is small in value yet sovereign in destiny. He does not need excess to steer his life. A quiet principle, applied steadily, can guide decades. It might be clarity. It might be kindness. It might be attention. Chosen once and kept, it will act like a constant term, shaping outcomes more than louder bursts of will. He can check his days against that constant the way a navigator checks stars. He rehearses consolation. In a widening world, many bright things drift away. The way to keep them is to keep their light, which is memory. He can build archives of meaning that need no permission from the future to be valid. A conversation written down, a story told to a child, a garden planted where others will sit. This is not nostalgia. It is stewardship of signal. He becomes part of the gentle preservation that lets cultures continue even as horizons recede. He accepts the ethics of scale. The night contains cities of light and stretches of dark. He does not try to illuminate everything. He attends to the room he can warm. The rest can remain dark without being neglected. Darkness is not an enemy. It is a reserve where possibility waits without pressure. He allows others their unlit places. He keeps a door open in case they wish to share the map later. He shapes hope that does not depend on urgency. The universe has no crisis of ending in the near term. It carries a long, generous future that privileges patience. He can organize his hope accordingly. It need not be frantic. It can be a durable hope, the kind that survives setbacks because it is not tied to a moment. It is tied to direction. Direction is outward. Direction is toward more room for understanding and for care. He learns to breathe with the world, inhale, and take in the present without judging it too soon. Exhale, and let go of what cannot be held without harm. Repeat. There is ritual in this that outlasts argument. It is almost a physics lesson distilled into breath. What expands is not the self at the expense of others. It is the field in which selves can move without collision. He does not grow by pushing, he grows by allowing. He holds a final image. A person stands under a night that is still widening. The constellations are as steady as one lifetime requires. The distant galaxies thin toward invisibility, but the nearby stars are enough to navigate any ordinary journey. The person lowers the need to grasp everything and lifts the will to care for what is within reach. Meaning is not scarce. It is a fabric that keeps making room. To live in that fabric is not to be small. It is to be right-sized, aligned with a geometry that proves serenity can be lawful. Night arrives without verdict. It opens. Clouds lose their edges, and the sky becomes a single patient tone. He looks up and sees not a ceiling but a slow widening that asks nothing from him except attention. Stars hold their local vows. Between them the fabric lengthens with a grace that is almost sleepy. Motion exists, and yet there is no hurry in it. The most relaxing fact presents itself in a form that the body understands before the mind does. There is room. There will continue to be room. Distance grows like a calm breath. Light carries the first reassurance. A photon leaves a distant shore and travels inside a field that is learning to be larger. Its wavelength opens. Its color moves toward rest. The traveler does not tire. It changes key, as if the path itself were a musician. This softening does not erase what it has to tell. It records time with more tenderness than a clock. The message that reaches an eye or a mirror or a cool detector says that growth can be written in tones rather than in shocks. It says that even across distances that cannot be walked, conversation remains possible when patience is given most of the work. Gravity supplies the second reassurance. Where mass gathers, orbits find compromise and keep it for long ages. A galaxy does not become unbound because the fabric grows elsewhere. It continues to spin its quiet grammar. A cluster holds its slow dance. A planet traces an ellipse that repeats without complaint. The largest story adds no panic to these smaller sentences. They remain legible. They keep their structure. The presence of islands in a widening sea makes calm take on shape rather than dissolve into vagueness. The background glow adds a third. It is nearly uniform in all directions, and the tiny ripples it contains are not warnings. They are fossils of sound that once moved through a plasma too warm for atoms to form. Their scale acts like a ruler that can be read at many times. A ruler built into the sky is not an instrument that wears down. It is a promise that measurement will continue to be possible. The promise is modest. It says that order is present at large scales, and that the order is simple to describe. When simplicity holds without cruelty, rest becomes easier. Time itself relaxes in a way that does not empty it. Ages pass, stars are born and darken, galaxies meet and merge. None of this interrupts the quiet outline of the whole. The outline is an easing toward a state where distances grow at a steady fractional rate, where the horizon takes on a fixed character in physical size, where the future is long without sharp cliffs. Fate does not arrive as a blade. It arrives as a climate. A climate can be lived in. It can be understood enough to make plans that fit. Horizons draw boundaries that soothe rather than frighten. There is a furthest past that can be seen, because light needed time to cross the widening field. There is a furthest future from which signals launched today will never arrive if acceleration continues. Neither boundary rebukes curiosity. Each frames it. Inside the frame there is detail enough for many lives of thought. Outside the frame there is mystery enough to prevent vanity. The pairing is healthy. It sets an honest scale for hope. The gentle driver of late-time expansion does not behave like a dictator. It does not tear bonds apart that have already found equilibrium. It does not ignite fires that burn the map. It offers a steadiness at the largest scale. A steady background selects for stories that can endure. Chemistry takes time and gets it. Evolution takes time and gets it. Cultures take time and get it. The universe steps back without stepping away. The gift is not noise or spectacle. It is duration. Instruments learn the lesson and reflect it. They quiet their own interference. They repeat measurements instead of forcing answers. They stack signals so small that a single night would miss them. The slow methods win. A plot gains a curve. A map gains a texture. A parameter gains another digit of clarity. The quiet of the sky recruits the quiet of craft. The match is almost musical. Tempo meets tempo. Speculation finds a way to be gentle too. Theories are not obliged to shout. A field that rolls slowly can explain a push that does not intrude. A constant value assigned to emptiness can provide a clean line that the data follow. A modification to gravity that hides where matter is dense and acts where it is thin can thread a needle without breaking fabric that was already well stitched. Each idea offers not a duel but a posture. The posture is calm, functional, and precise. If a person seeks consolation in a setting like this, it will not be the consolation of rescue. It will be the calm that comes from alignment. The outward motion is in no hurry. A life can place its hopes inside a practice that does not demand immediacy. The practice can be the patient refinement of a craft, the cultivation of a relationship, the care of a place, the education of attention. The universe does not applaud, but it does not interrupt. It allows. The allowance is enormous. He thinks of the most delicate distances, a few 100,000 kilometers that keep a moon aloft, a handful of astronomical units that hold a system together, tens of thousands of light years for a disk of stars, millions for a group, hundreds of millions for a cluster, billions for a web of filaments that thin as the sea widens. Each scale accepts a different kind of rest. Each owes its stability to a balance between attraction and the gentle drift of the whole. The coexistence of all these rests is the quietest wonder. Even endings become softer. A star may flare and collapse, but such events become rarer in the long view. Most lights will dim without catastrophe. Black holes will one day empty in particles so faint that only the book of equations will keep track. Matter may persist, or it may erode on timescales that do not fit any calendar a mind can hold. In either case, the pace remains unthreatening to beings who measure time in days and years. The picture is not tragic, it is spacious. A final comfort arrives from the absence of a throne. No point is a favored center. Every observer who measures far galaxies will find the same relation between distance and retreat within the small roughness that local weather imposes. This symmetry is not just a mathematical neatness. It carries an ethic. It says that the fabric gives room without preference. It says that those who look out from anywhere are permitted to read the same large story. Shared law is a kind of grace. He lowers his gaze and sees that the same grace can be practiced near at hand. Make room, keep orbits regular where bonds belong, and let the spaces between grow quietly where distance helps. Accept limits that come from honest horizons. Measure with care rather than with impatience. Choose constants to guide effort, and keep them small and firm. Welcome the unknown without treating it as an enemy. These are direct translations of a physical setting into a way of life. They do not lean on metaphor. They are geometry turned into conduct. The night deepens. Crickets test a rhythm that stands apart from the arc of the Milky Way. Air cools by degrees. A person stands still and finds that stillness is not absence of movement. It is a posture that suits a world where the largest motion is a stretch that never jerks. He breathes. The breath slows. Thought slows, not into dullness, but into precision. The mind can hold one sentence at a time. The sentence is simple. There is more space. There will be more space. Inside that statement is a long permission to be careful with the hours, to be kind without offset, to wander without greed. Drift into infinity does not mean forgetfulness. It means a method. The method is patience that acts. There is a gentle picture to carry to sleep. Imagine a shore without waves. The water is not still. It rises so slowly that the eye does not catch the motion, yet the tide is faithful. Stars are lanterns set back from the edge. They do not step closer. They do not recede in panic. The beach becomes longer, while the lanterns keep their appointed glow. A person walks there, hears a cricket chorus, feels the air cool, and understands that the world can change without threatening its shape. In this picture, light is a lullaby that has crossed a patient ocean. It arrives redder than it left, the way a song sung softly by the time it reaches a child's room. Gravity is a chair that keeps its place, sturdy under the body, even as the room grows larger by the hour. The horizon is a curtain that no hand needs to draw. It adjusts itself with the ease of a cloud, letting enough of the stage be seen for comfort, and leaving the rest in darkness where possibility can rest. The mind that holds such images does not need to rush. It can set a single intention for the next day, and let that intention carry the weight that noise would normally take. It can allow conversations to spread into a larger field. It can remember that kindness behaves like a constant term, small in value and sovereign in fate. Now let the shore fade. Let the lanterns blur into a soft band. Let breath find the long pace that matches the long pace of everything. The night is wide. The future is long. Nothing urgent waits at the edges. Sleep can arrive like a slow tide, and in that tide the heart can drift with perfect safety.